Welcome everyone. We are going to develop some sample code to manipulate a linked list. In this case, what we're going to do is we're going to develop code that appends new nodes to the end of the list instead of prepending at the beginning of the list. The sample code that we've seen so far prepends at the beginning of the list. So one way to do this would be to keep a tail pointer on the list. So the tail pointer on the list would always point to the last node. So if the list is empty, it would point to null. And if there's just one node on the list, the head pointer and the tail pointer would both point to that one node. If there's multiple nodes on the list, the tail pointer would always point to the last node. And then we would use that to add something new at the end of the list. Second approach is to create a function called find the last node on the list, and then use that when we want to append to the end of the list. This could come in handy if we want to use it for other things, as we'll see later on. So this approach of writing this function is what we're going to use. So we're going to start with the original code that we had. So if you want to go and look at bit.ly/141 starter code, you could grab that code yourself. And then as we go and develop this, you can edit that code. And I encourage you to do this, not to just watch what I'm doing, but to experientially go through it, go through the pain of making mistakes and having compiler errors, because ultimately that helps you to understand the material better. So if we go and take a look at that starter code will take you to a document that looks like this. And this document is here. And then in here, there's a link. So if we follow this link to this bookmark, it scrolls us down. Actually, it's just one page down, but in the future, we'll have other code in here. And this is the code that we've seen previously, where we have a node that's declared with the data, and then a pointer to the next part of the program. And then we have the code to display the list, where we have a loop that goes through, print out the data, and advance the pointer to the next one. And then here we have the code where we read in user input values, and while it's not a -1, we get a new node, store the data from the user input, and then make that pointer point to what the head of the list currently is pointing to, and that implements adding a new node at the front of the list, and then resetting the head pointer to be this new node. Finally, at the end, we call display list, it prints it out, and that's what it does. So this is the starter code that we're going to use, and we'll get back to that in a little bit. For now, we want to just think about what are the ideas for doing this. So we want to write this, find the last node on the list. What are the different cases we have to consider? And so we want to make a list of what those cases are. Then we want to draw some pictures, before and after pictures of each one of what happens when we get this. And I think to find the last node, I think we want to change this. I think we want to return a node star. We want to return a pointer to the last node on the list. So that's the first change that we're seeing right here. Okay, so I encourage you right now, pause this video, think about what are the cases we have to consider, and first make a list of what those are. So I'll give you a moment to do that. I'm actually not going to pause this video. I'm going to have you pause it. So welcome back. I hope you came up with a list of cases. So the list of cases that we're going to see here are, let's say the list is empty. So if the list is empty, then what happens? And it may turn out that we get to consolidate some of these cases. So list is empty. Number two, how about if the list has a single node? Then what do we do? Then how does that work, right? And then three, the list has multiple nodes, okay? So let's take each of these in turn. Let's draw before and after pictures and see what happens. Let's start out where the list is empty. So list is empty. So we'll draw a little picture of the empty list. And in our case, we've got the head pointer that comes in here. So we've got p head that's being passed in right there. And so if the list is empty, we would have p head is our pointer, and the p head pointer is null, like that. So if the list is empty, then so we need to know, like, what is it? So if that's the case, then we want to return also null, because there's nothing on the list. So returning the last node, there's nothing there, so we can't return anything. So not only we need to also have the condition check to find out, right? So what would be the condition? So here, to figure out if that's the condition that we're in, it would be something like if p head is equal to null. If that's the case, and then the value that we're going to return from this function is we would return null in this case. All right, so if the list is empty, that's what we would have. So we could combine the condition and the value into the actual code to do this. Well, let's think about what if the list has a single node, what would that look like? So if the list has a single node, so let's draw our picture of what that is. So now p head would point to a single node with a value in it. So let's say we've got our head pointer, and this points to a single node. And let's say this has a value 3 in it, and then its next pointer is null. And so the condition to see, like, is this the case that we're in, would be like, well, if p head arrow p next equals null, then we know that we're in this situation where the list has a single node. So our condition here would be if p head arrow p next, if that one is equal to null. If that's the case, then the value that this is going to return, remember, we're trying to get the value of the last node on the list. So in this case, this is the last node on the list, and the address of that last node is right there. So we're going to return p head. It is the address of the last node on the list. So now let's think about if the list has multiple nodes. So this is this case down here. So this should be number 3 on the list. So let's take a look at this one. So if we have multiple nodes, let's say that we have p head points to a node, which itself points to another node. And for good measure, why don't we put 3 of them in there, which itself points to another node down there like that, right? And then that one points to null. So let's say our input was 3, 5, and 7. And so because we're prepending in this case, if we were prepending, our list might look like that, if that's what we had. And now what we need to get is we need to get the address of this last node down here. So how do we do that? So we don't want to move p head down the line. We need some other pointer, maybe p temp. And remember, what we're trying to do is we are trying to find the pointer to the last node on the list. So we want to find the last node on the list, we pass it the head pointer, and we want to return the address of the last node on the list. So if we come down here and take a look at this case, the list has multiple nodes. So let's say we pass it p head, but let's say we catch it as p temp. What did we call it up here? We called it p head, right? So we pass p head, but when we catch it, we can call it p temp to make it clear that it's a value parameter, that we're not trying to change the head pointer of the original list. So if we come in with p temp, and p temp, when we catch it, is equal to the node, the first node, and I'll put it in a different color to make it clear that it's the value that's inside the function. So p temp, pass it as p head, catch it as p temp, it points there. So we want to move it down to here, we want to move it to here, and we want to keep moving it until we get to the situation where it's pointing to a node where that node itself, its next pointer, is null. So so we're going to have some condition in here, right? So this is going to be while, so we're going to have some condition. So up here we had if p head arrow p next is equal to null. So the condition down here was going to be else, right? It was going to be the opposite of this one. So we would have else means it's not null, which means there's more than one in the list. So down in here, what we're going to want to do is we want to go through and we want to say while p head, or in this case p temp, while p temp, while this thing, while p temp arrow p next is not equal to null. Then what we want to do is we want to take this pointer and make it point to the next one, make it point to the address of the next one. Address of the next node is stored here. So what is that? That's ptemp, arrow takes us into the box. Pnext takes us to this part. So we'd say ptemp equals ptemp arrow pnext right there. So we would say ptemp equals ptemp arrow pnext, like this. Okay, so it advances it to the next one. Now, when it stops, so here, is ptemp arrow pnext equal to null? No, it's not, so it advances it, so it comes over to here. Is ptemp arrow pnext equal to null? No, so it advances it over to here. Is ptemp arrow pnext equal to null? Yes, it is. Because we go into the box right here, ptemp arrow pnext is equal to null. So now ptemp points to this last node, and now we would want to return the value of this last node. So we would return here, and I'm going to put this over here, the value to be returned in this case is ptemp after we do this code. So now what we're going to do is we're going to go and take these conditions and try and write this code. So we have 3 conditions. We're going to see, well, let's see, the list is empty. If the list is empty, and this is how we check to see if it's empty. If that's true, then we're going to return null. If the list is not empty, so if there's a single node, then we return phead. Else, and we come down here, we need to iterate through the list, so we're going to have this in there. So while there's a next node, we advance to the next node until we get to the last node. In this case, we return ptemp. So given these conditions, and I'll try and put them all on the screen for you to see right now, let me encourage you to go take the starter code and then put these in, and then inside of main, test it to see, can you in fact can you create a list with multiple nodes in it using the starter code? And then at the end of that code, can you call this function and then print out the address of the last node on the list? So don't just blindly go ahead right now. If you can write this, then you'll really get it, then you really understand it, as opposed to just sort of watching me do it and go and be like, oh yeah, good enough, right? You need to be able to write this yourself. We've got the building blocks here for you to use. So go and write that and take a few minutes to do it. Pause this video, then come back and compare and see what you have.